Hey everyone, I'm Nick Raboy from MongoDB, and in this tutorial we're going to see how to create an AWS Lambda function, so a serverless function using Kotlin and MongoDB. So this particular tutorial is going to leverage the fairly new Kotlin driver that MongoDB offers, and we're going to see that it's pretty easy to create these serverless functions because in the end, Kotlin will create a jar file that will allow us to upload to AWS and use their Java runtime. So even though we're using Kotlin, it still will work on the Java runtime. All right, so up on my screen, you'll notice that I do have IntelliJ. This is what I'm going to be using for this tutorial. Honestly, you can use whatever you want. It doesn't really matter. This is just a convenience thing for me. But what I'm going to do is I'm going to create a new project. And this new project, I'm going to go ahead and call it Lambda Kotlin. And I'm going to save this to my desktop. This is going to leverage the Kotlin language. I'm going to be using Gradle for my dependencies, so my dependencies like MongoDB. And that Gradle file, in the spirit of Kotlin, we're going to create it as Kotlin rather than Groovy. And I'm just going to go ahead and create this project. Now you'll notice that the project is created. We're going to be editing the Gradle file. We're also going to be creating a new project file of our own to store all of our code. We're going to focus on getting things created and up to speed first, and then we're going to worry about actually dabbling with MongoDB or dabbling with AWS Lambda. So all of that's going to come later. So the first thing that I want to do is I want to open up my build.gradle.kts file. We're going to add a few dependencies here to make our project successful. The first thing that we want to do is we want to add a package that will allow us to create a fat jar. So AWS expects us to either upload a jar with all of the dependencies and stuff built into it, or a zip with a jar in it. We have to do a fat jar because if it's missing all of our dependencies, we're probably going to get errors related to either the MongoDB driver or the Lambda dependencies or something else. So the easiest way to do that with Kotlin is to use a package called shadow, and we can create what's called a shadow jar. So to do that, what we can do is we can say id, and we can say com.github.john.ringleman.shadow. And we're going to provide it a version. And for this particular tutorial, we're going to say 7.1.2. And we can go ahead and save it. We can refresh our dependency list if we want. And it'll go ahead and get that dependency for us. So next we want to define our dependencies. So our dependencies will include the Mongo driver for Kotlin. It will also include the dependency for Lambda. So inside of the dependencies section, what we can do right below the test implementation, let's go ahead and add a few dependencies. So what I'm going to do is I'm actually going to paste them in, and I'll explain what they mean. So the first two are related to AWS Lambda, and it will allow us to create a class, and it will basically work with AWS Lambda how it expects. Next up, we do have the MongoDB BSON package, so that way we can work with BSON data, and as well as the MongoDB driver for Kotlin. And this is just going to be a basic example. We're not going to do anything extravagant here, but it will set the foundation for more complex projects. The next thing that we want to do is we want to define what our main class is, because our shadow jar dependency depends on what our main class will be, and that's going to be where we add all of our code. So what we want to do is we want to define application, and we want to say main class dot set, and this is where we would define where our handler is going to be. So our AWS Lambda handler, and the naming convention is not too important as long as we're consistent throughout. But we're going to say example, so it's going to be part of the example package, and it's going to be in a handler class. Now you'll notice that it probably is throwing some kind of error right here. Inside of our plugins, we probably also want to add the application plugin, and it should clear things up. And it did. It just took a second to reset. So I'm going to go ahead and import all of these Gradle dependencies. And at this point in time, we should be ready to start coding. If we end up getting any kind of funky errors in the future as we progress, we'll revisit this Gradle file. But ultimately, we really just wanted to get the shadow dependency for our jar, and we wanted to add our Lambda and MongoDB dependencies. So now what we want to do is we want to actually create our class handler, and we want to create it in the example package. So we're going to go to main, we're going to go to Kotlin, and we're going to say create a new package. And this package is going to be called example. And inside the example package, we're going to create a new Kotlin class. And this Kotlin class is going to be called handler. So it should look something like this. And remember, we're using Kotlin, not Java, and it's not a strict requirement that we have to use IntelliJ. You would just reproduce these steps however you see fit for whatever IDE or even shell tool that you're planning on using. All right, so we have that done. So I'm going to go ahead and paste in the import lines. This is going to be relevant to MongoDB for Kotlin, and it's going to be relevant to Lambda. And everything that we plan to do is going to be inside of this handler class. And we're going to make some modifications so that way it's up to spec when it comes to Lambda, because we have to do things the Lambda way. So what we're going to do is, first of all, we're going to extend the handler. So it's going to say we're going to extend it to request handler, and this is going to be of type map. So we're going to have a map of a string value and a string key. And for now, what we're going to do is we're going to say void. So basically what we've said by extending the request handler is that we're going to be able to accept a map of strings, and the response for now is going to be basically null or void. And that's going to change. We're going to be returning actual data from MongoDB, but for now it's easiest just to leave it at that so that way we avoid any kind of errors. Now what we want to do inside this handler class is we want to create an override function. So we're going to say override, and we're going to say fun, and we're going to say handle request, and we're going to accept an input. So this input, because we've defined it in the request handler as a map of string, it also needs to be a map of string. So we're going to say map string. We're going to include the context, and we're going to return void because that's what we're expecting to return as of now. So we're going to say return null. Now let's start worrying about the MongoDB side of things. So what we want to do is we want to establish a connection to MongoDB, and we want to go ahead and get a reference to our database and a reference to our collection. And this is where I'm going to be switching between the MongoDB Atlas dashboard, and I'm going to be switching between the code. But let's go ahead and get the code in place first, and then I'm going to walk you through what that looks like inside of MongoDB itself. So outside of the handle request function, this is where we want to define our MongoDB client. So I'm going to say private value, and this is going to be Mongo client, which is our name. And we're going to say Mongo client equals, so Mongo client is the type. We're going to say Mongo client dot create, and I could just hard code a connection string in here. It's not advisable. It's definitely best practice to use some kind of environment variable or configuration file, so that way you don't accidentally commit this information to, say, GitHub or somewhere else, because your MongoDB connection information has your username and password in it. So it's a good idea to make this excluded from your code. So in our example, what we're going to do is we're going to say system.getEnv, and we're going to provide a environment variable for it. So we're going to say MongoDB Atlas URI. So that's just the name of our future MongoDB environment variable. So this environment variable, we're going to be adding it to the AWS Lambda function in the cloud. So we won't ever need to worry about actually hard coding this in our code. So we're going to assume this connection will be valid as of right now. Inside of the handle request, this is where we want to get a reference to our database and our collection. So I'm going to say value database. This is going to be of type Mongo database, and I'm going to say Mongo client dot get database. And for this example, if you've ever worked with MongoDB, and I'm going to show you this in a moment, if you've ever worked with MongoDB, there are sample data sets available. I'm going to be using the sample mflix data set, and you can load this directly in MongoDB. I'll show you in just a moment, but I'm going to say sample mflix is my database name, and I'm going to say value, and I'm going to say collection, and I'm going to say Mongo collection. This is going to be of type document, and it's going to be database dot get collection. And for this collection, I'm going to say movies. So sample mflix is kind of like IMDb, and it just has information about movies. So I'm going to pull from the movies collection, and that includes things like the title, the plot, things like that, anything related to the movie itself. Now, if I go into my web browser and I go to MongoDB, so this is the MongoDB dashboard that I was talking about. So I have a examples instance created. If I wanted to load a sample database, I could say load sample dataset, and that would include sample mflix, and that would include the movies collection that I'm working with. But what I'm going to do is I'm going to say browse collections, and it actually looks something like this: sample mflix, movies, and then we have quite a few movie documents. And the data for this example doesn't really matter because it's such a simplistic example that we're going for when it comes to MongoDB and AWS Lambda. But in case you're curious. Now, what is important to us is if we go to the database tab, what we want to do is we want to click connect. We can scroll down, we can go to drivers, and we can choose the driver that we're working with, in this case Kotlin, and this would be the connection string that I want to use. Now, I'm not going to add this to my code. I'm not going to add this to my local environment variables. This will be used when we go to the AWS Lambda dashboard. But this is what we would copy in. And what we want to do is we would want to create a username and we'd want to create a password. So if you close this, if you don't already have a username and password, you can go to the database access rules and you could add a new database user. And then you would fill that in when you paste in your connection URI string. You'd also need to set up some network access rules so that way Lambda can actually reach MongoDB. But that's out of the scope for this tutorial. We're just going to open up the access to all IP addresses. We're going to give a pretty generic user, and it should be enough to get us going. So going back into our code, now we can actually focus on communicating with MongoDB. So in theory, we have a connection established. So we would create this Mongo client. We would get reference to our database and collection. But we're not actually querying MongoDB. We're not inserting any data. We're not doing anything particularly interesting at all. For this example, we're just going to query MongoDB. And the best way to handle that for this example is if we go into the handle request override function, let's go ahead and create a find operation. So we can say val results, and the result type is going to be list, and it's going to be of type document inside of that list. And we're going to say collection dot find. So this is a find operation. It's going to find one or more documents, provided that they exist. And we're going to pass in a filter in just a moment. But we're also going to limit the result set. So because we're using the movies collection has tens of thousands of documents. We don't want to return all of them. And for this example, we're not going to be working with cursors. So what we want to do is we want to just maybe limit that result set to 5 documents. And we also want to convert it to a list because that's what we're expecting as the end result. So we're going to say to list. We don't have a filter in here yet, so we're basically going to say we're going to return all documents from this collection, limiting it to 5. But let's go ahead and improve upon that. We're actually going to create a filter here. So I'm going to say var, I'm going to say filter, and this is going to be of type bson, our filter, and we're going to say bson document. And we're going to go ahead and add that to this particular line on line 24. So we have a filter, it's empty, it's still going to get all documents here. So let's go ahead and improve upon this. Let's go ahead and say that if the user provides us a title, let's go ahead and search based on that title. And we're not actually doing a search, we're doing just a filter, so a match query. Searching, if you want to do an aggregation pipeline in MongoDB, you could do Atlas search, which is full text search, but that is out of the scope for this particular example. So what we're going to say is we're going to say if, we're going to say input, so input being the user input for this particular function when they call it. We're going to say contains key, so if it contains a key called title, remember we're working with a map and it's of type string for the key and string for the value. If we include a title, so it contains that key, and we're also going to say if the input is not, basically we want to make sure that it's not null or empty. So we're gonna get the input. We're going to say title, so the title key exists. Now we're just checking to see what that value is. So we're going to make sure it's not is null or empty. And as long as it passes that criteria, so it exists and it contains data, we're going to set the filter to that particular value in the title. So we're going to say filter equals filters.eq. We're going to say title, and we're going to say input.get, and we're going to say title. So the first title here is the actual key inside of MongoDB, so our field, and this would be our value. So that's what our filter is going to be. So as long as the field in MongoDB, the title field, matches whatever this value is, then return those documents. So they don't need to match. It's just coincidence that they both match in this particular case. So if a title exists, we're going to use that as our filter criteria, and we're still only going to limit our results to 5 records maximum. It may never reach that much. Depends on the movie that we call. Now we're still returning null here. We need to make an adjustment. So instead of void, what we want to say is we want to say list, and we want to say document. So that's the type of data that we want to return here. We're also going to need to make that adjustment on line 17. So we're going to say list document as our return. And now we don't have to worry about null. Instead, what we can do is we can return results, because we're working with a list here, and the type is list of document. So we're returning the results. Now, in theory, this should be enough to upload to AWS Lambda. It should work. And once again, we're going to get that connection string when the time comes and add it to Lambda. But the code itself should be good. So what we want to do is we want to build our jar. So go ahead and open up whatever menu you're using. This could be command line, and you could be using Gradle directly from the command line. I'm using IntelliJ. So what I'm going to do is I'm going to say Gradle, and I'm going to say shadow jar, because I'm using the shadow jar plugin. I'm going to hit enter. So it says that it finished successfully. So if I go to my Finder, I can actually find it inside of my project. So I'm in Lambda Kotlin. I can go to build, and I can go to libs, and it should be there. It says Lambda Kotlin, and then it's got all this other stuff attached to it. I can upload this jar as is, or I can add it to a zip file. It really depends on what you're up to and what your project calls for. But this is the file ultimately that I would want to add to AWS. Now let's go back to my web browser. So I'm going to go to my Lambda dashboard here, and I'm going to create a new function. This function I'm going to author it from scratch. I'm going to call it maybe MongoDB example, and the runtime, it's not going to be Node, it's actually going to be Java. So after I've chosen my Java runtime, I'm going to make sure that I choose the architecture that I want, and I'm going to go ahead and create the function. All right, so inside of the function landing page, there's going to be a few steps that we want to do. First step, what I want to do is I want to upload that jar file. So like I said, we're going to go to the libs directory, and I'm going to upload that jar file directly, and I'm going to save it. All right, so it's uploaded. We're not quite done yet though. So if we look at our handler information for the runtime settings, this is not correct. It could be if we've decided to do it this way, but based on our project that we've just done, that's not correct. So we're going to edit it. So our package is called example. Our actual class is called handler, and our actual function is called handle request. So just make sure that you modify it to match whatever you're set up with. So I'm going to click save. All right, so that's done. Next thing I want to do is I want to go to configuration, and I want to go to the environment variables. This is where we add our environment variable string. So I'm going to say add environment variable. We called it MongoDB Atlas URI, and now we actually want to add that value in. And you could do different encryption options for these environment variables. I'm just going to paste it right in. So I'm going to go back to my MongoDB Atlas dashboard here. I'm going to go to data services. I'm going to click connect, drivers, Kotlin. I'm going to copy this. I'm going to go back into Lambda. I'm going to paste it in. I will have to update the username and password. So what I'm going to do is I'm just going to populate this and click save. The next thing that we want to do is we want to test it out. We've uploaded everything. We've added our connection information to Lambda itself. In theory, we should be good now. So I can go to the test tab, and if I scroll down, I can just create a very basic test here. I don't really need to name anything if I don't want to. I don't need to save it. The event JSON, we're going to leave it like default for now because we don't have anything looking for key 1, key 2, key 3. We're looking for title. So it should ignore any extras. So what I want to do is I want to click test. So the test finished. Let's go ahead and check out the details. So looking at the details here, it looks like it found data. Now remember, we're limiting our results to 5, so I do trust that there are a maximum of 5 movies here. Remember, this collection has many of thousands of movies, so 5 will definitely be the maximum here. It shouldn't be less. Now let's go ahead and make a change. Let's go ahead and go down. We're going to test again, but this time around we're going to say title. We're going to say this one's going to be the Terminator. We don't have to remove these others because we're not doing any kind of checks, but I'm going to remove them anyways. Just keep it nice and clean here, and I'm going to run the test again. In theory, we should have hopefully just one movie come back. So if I go up, we have a human-looking cyborg, so this looks good. This is probably the Arnold Schwarzenegger movie that I wanted, and the result set is just 1 here. It's very short. So it did work out successfully. So just a recap on everything that we did real quick. So inside of our build.gradle file, this is a Kotlin version of it. We did include a plugin so that we can create a fat jar, so a jar bundle of our project and dependencies. We defined the main class here for our project, so this would work with our shadow dependency. So we added the Lambda dependencies. We also added the MongoDB dependencies inside of our code. We're accepting a map of strings. So like you saw in the test, I was able to add a title in that map. So in that JSON object, we are establishing a Mongo client. It uses an environment variable. We're getting our database and collection references, and we are doing a simple find operation on our data. So nothing too extravagant, but you can definitely take this and you can build pretty powerful things in a serverless manner. So in my example, I was using a free tier of MongoDB Atlas. So I was using a free cluster size. If you wanted to go full serverless with this example, you could create a serverless instance of MongoDB. So that way, not only does your application scale for demand, so your Lambda function will scale, but your database will also scale with demand. So it's not always on. You're only being billed per usage, and it could be a very convenient and efficient way to do business with your applications that use MongoDB and Kotlin. If you like this video, please take a moment to hit that like button on the video, subscribe to the YouTube channel, drop me a comment. If something didn't make sense, let me know about it. If you like this video, if you want to see more videos like this, also drop me a comment. I'd love to produce more on Kotlin or even AWS. Until next time, have a great rest of your day.